Delta Parquet tables are the default data format in OneLake, and I think that every person working with Mixed Fabric should understand the basics of this powerful open source data format. And that is exactly what we are going to do in this video. We are going to learn the basics of Delta tables, ways to optimize them, and also partition them. And then we are going to talk about Lakehouses as a data store and dive into shortcuts that allow you to virtualize data to OneLake. And all of this is going to be explained in beginner-friendly way by using demos in Fabric to clarify these topics. Stay tuned for more. Welcome to the video. My name is Aleksi and I'm a data architect and a Microsoft Data Platform MVP. And on this channel I cover Mixed Fabric related topics. Today we are going to learn about Lakehouses and Delta tables that are one of the core topics to understand when storing data to Fabric's OneLake. But now, without further ado, let's get started. Let's first cover an overview of the Lakehouse and then dive deeper into specific parts of this data store and Delta tables in general. First, we have to have a Fabric environment to which we can then create a Lakehouse. The cool thing about Lakehouse is that it can store files and tables. So basically in this data store we have two main sections. A good thing to recap here is what we covered in the previous episode, that when we are storing data to Lakehouse, we are actually storing it to OneLake under the hood. And using Lakehouse is just one of the ways of storing data to OneLake. That is the underlying data store in Mixed Fabric. That is basically this unified data lake for entire organization. And there is only one OneLake per fabric, like the name implies. Also, a good thing to know is that OneLake is based on the same technology than Azure Data Lake Storage, and Microsoft has just repackaged it into Fabric into this software as a service version of Azure Data Lake. So, like said, we can store files and tables to the Lakehouse. This means that we can store data in very raw formats like CSV and JSON files, and thus Lakehouse is an excellent data store for ingesting and archiving data, since you can land the data there in any format you want. So typically in Medallion architecture, Lakehouse is used as a bronze layer data store for this reason. And of course it can be used for silver and gold as well. And when I say that you can store data in any format you want, I really mean that. And you can store more untraditional data there for data engineering purposes like video and audio files if you so desire. For tables, Lakehouse uses the Delta Parquet format as its default data format. Delta Parquet is this very powerful and optimized open source data format that is the same format that is being used, for example, in Databricks. Delta Parquet is also the default data format that is used in the entire OneLake, and when we cover more Fabric data stores, we will run into Delta Parquet format over and over again. Also, later in this episode, we will talk about optimizing and maintaining those Delta tables. One very cool thing about the Lakehouse is that it has some very nice data virtualization capabilities. This means that we can use Lakehouse to access data that is physically sitting in some external system or data store. This technology is called shortcut, and we can, for example, create shortcut to AWS S3 bucket or Azure Data Lake and bring data to Lakehouse and Fabric using this method. This will mean that the physical data will stay in the external location and is only shown through the Lakehouse and OneLake. So from the Fabric UI, you would be able to see those files even though those files are actually sitting somewhere else. There are many benefits of using shortcuts, and we will talk more about shortcuts in the next slide, but to name a few benefits, data doesn't need to be duplicated and it stays always up to date. Also, the cool thing is that this technology is not only for files, and you can shortcut tables as well. For example, if you have an existing Azure Databricks environment where you're using Delta tables, you can easily shortcut those Delta tables to Fabric Lakehouse and use them like those tables were sitting in Fabric OneLake. Cool. Now we have data in our Lakehouse and we would like to access it. Well, there are several different interfaces that can be used to access Lakehouse data. We can of course access the data using Spark, then we have the T-SQL interface that provides similar interface than in Fabric Warehouse, but with the limitation that it only allows reading the data. So this interface does not allow writing data back to the Lakehouse. And since OneLake and Lakehouse are based on Azure Data Lake, we can use ABFSS or Azure Blob File System API to access the data. Then we have some other endpoints like REST and analysis services that can be used to interact with Lakehouse and its data. Also, key thing to remember is that these interfaces are powered by Masked Fabric capacity. So if you don't have capacity running, you can't access the data either. Then lastly, we have the consume layer and the different tools that consume data in a Lakehouse. Almost every tool in Fabric is able to at least read data from a Lakehouse. And you can use tools like data pipelines, data flows, notebooks, and event streams to interact with Lakehouses. And I would say that the most native tool for accessing this data store is the notebook by using Spark. Also, you can access data in a Lakehouse using Power BI and have it on your reports. And this access is not only limited to Fabric services, and we can use those different interfaces to access data with many different external tools and services like Azure Databricks, Data Factory, or with some custom application. Next, let's talk more about shortcuts since they are a core concept to understand with Lakehouse. Many of the core features we already covered on the previous slide, but as a quick summary, shortcut allows virtualizing data from an external system via Lakehouse, which eliminates the need for data duplication and makes sure that the data is up to date with the source since it is not physically copied. These shortcuts support ever-expanding number of sources, but at the time of making this episode, the supported sources are Fabric data stores, ADLS or Azure Data Lake Storage, Amazon S3 or S3 compatible sources, Dataverse, Google Cloud Storage, and as a newest arrival, Apache Iceberg. And then these shortcuts can be used to bring in files or tables depending on the source. However, shortcuts are not only for connecting to external systems and data stores, and they play a key role in sharing data in Fabric between its internal data stores. One very common use case for shortcuts is to shortcut data from one lakehouse to another. These internal shortcuts work for files and tables and can be used across workspaces. Also, there is a concept called shortcut cache that is not super relevant for DP600, but let's cover it quickly. This is a workspace level setting that can be turned on. In practice, this cache will store frequently accessed data locally in OneLake. For example, in our picture, if we would be reading the JSON file from S3 bucket via shortcut and we would have a shortcut cache enabled, if we would read it once, this file would be stored to the cache and following reads would be using that cache rather than the file that is sitting in the S3 bucket. This would improve the performance of the shortcut since we wouldn't have to do repeated reads to that external S3 location. This process is happening entirely under the hood, and if you're not aware of this caching, you won't be able to tell any difference than maybe that you can read data a bit faster in some cases. So this cache is completely invisible for users. Also, when using this cache, you don't need to worry about that you would be reading some old data, because this cache will keep track of those files from the source, and if the source file is updated, then the read is redirected to the source file rather than cache, and the cache is updated. These cached files are then kept for 1 to 28 days depending on your configuration. Also, files larger than 1 GB are not cached at all, and currently this caching is supported for Google Cloud Storage, S3, S3 compatible, and on-premises data gateway shortcuts. Next, let's cover the basics of Delta tables since they are good to understand in order to understand optimization and maintenance topics that we're going to cover next. In this example, we have a Delta table called person, and it is in the DBO schema of our Lakehouse. Even though this table looks like a traditional database table when using and interacting with it, it is actually Parquet files and folders under the hood that store data in a columnar format. Then we have a Delta log that keeps track of those files. Then we can use Delta table in a very similar way we use traditional database tables, but what happens under the hood is a lot different. For example, when we insert some new data to the Delta table, the logic will actually write new Parquet files to our Delta table folder and also update the Delta log about those new files. And then when we keep doing more and more inserts to our Delta table, more and more files will appear. Other operations like updates, deletes, and merges work a bit differently. For example, if we want to delete data and run a delete statement to our Delta table and delete one row, the Delta logic is not actually going to delete any data. Instead, it will mark the file where that specific row is and old or not in use anymore, and then create a new file without that row to replace that old file. Then also Delta log is updated to know that there is a file that is no longer in use in the latest version of the table. So in a sense, we start to build this version history of the data, and you can think about Delta table as this smart version control table. And due to this nature, Delta tables have some cool features like time travel that allows you to look at the past versions of the data. Also, Delta tables support ACID transactions, which means that you can reliably use and read the data even though somebody would be writing it at the same time. Then schema evolution is supported that allows adding new columns to the table based on the incoming data. However, the issue that might happen over time is that Delta table will get very large and have many small files, and some of those files could be irrelevant since they are older versions of the current data. Luckily, there are ways to maintain and optimize Delta tables that we're going to look at next. The first command or method that we can use to make sure that our Delta tables stay in good shape is to use the vacuum command. This command will clean unused data files from our Delta table folder. Basically, it will delete those old files that are no longer used by the latest version of our Delta table. This will have an effect to the time travel feature of the Delta table, since this will physically delete data based on the configured time period. We can, for example, run vacuum for files that haven't been used for 7 days. Of course, after running this, we can use the time travel feature to travel only to that point in time and no longer backwards, since that data no longer exists. The primary goal of the vacuum is to free up space in our OneLake. Next, we have a command called optimize that will combine those smaller files into bigger ones, so that when you're querying the table, there is less files to scan, which will then result to faster query speeds. Lastly, we have a V order that stands for vertical order, and it is a write-time optimization and can be ran with optimize command. Also, it can be turned on so that it's always on when writing the data. V order will group similar values together so that they are faster to query, and it will especially speed up queries with filters. The minor downside is that when turned on, it will slow down writes a bit, around 15%, but should make reads significantly faster, and thus V-order is a good option to have turned on and is enabled by default in Fabric, which in my opinion is a good thing. Now let's take a look at how partitioning works with Delta tables. Here we have a simple Delta table representing sales data with 3 columns: category, region, and amount. Based on the previous slides, you should be already familiar that under the hood this table looks like this. So we have a folder for the table, and then we have the Delta log and a Parquet file with the data of the table there. What if we would like to then partition this same table by using the category column? If we would do that, then this table would look like this under the hood. So what exactly happens here? Basically, when we create that Delta table, we tell the engine that we want this table to be partitioned by category column, and this will then alter the physical folder and file structure of the Delta table under the hood, even though the table representation will look exactly the same. So, partitioning means dividing your table into folders, meaning subfolders, based on one or more columns in the data itself. When we partitioned the sales table by using the category column, we got those folders category A and category B, and under those folders we then have data for specific rows. So in the Parquet file under the category A folder, we have the first 2 rows of the table, and then in category B folder we have the last 2 rows of the table. And like the first bullet says, we can actually partition by using multiple columns. And here we can see how the folder and file structure would look like if we would partition by category and region. So, what is the benefit here? Well, when you use partitions and then you query and filter the data, those queries can be a lot faster if they only hit a specific partitions. The most common example is to use partition column in the where clause of the SQL query, which then means that the engine only has to read files in that specific physical folder and no need to go through all the folders and files to find those rows. But I really want to emphasize here that partitioning is an optimization method for very large Delta tables, and having this kind of 4-row Delta table that we have here is not ever going to be a good candidate for partitioning. Partitioning is typically used when you have like hundreds of gigabytes of data and millions of rows in a single Delta table. Also, it is essential to choose partition columns carefully to end up with partitions that make sense and really speed up those queries. For example, using a column with many different values, like in this case the amount, would be a very bad choice, since the table would become super fragmented to small Parquet files. Also, the amount column is probably not the one that users of the table would be using as a filter in their queries. And lastly, I want you to know that there is this tool called OneLake File Explorer that integrates directly to your Windows File Explorer, and you can use it to interact with files in OneLake storages like Lakehouses. I wouldn't use this directly to interact with Delta table folders other than maybe delete them, since Delta tables are not meant to be interacted with this way. However, this tool is great for updating and adding new files to Lakehouse's file section where the raw files are. I can see that this tool can be beneficial to business users that want to update some reference data that is sitting in a Lakehouse. But now let's go to Fabric and talk more about Lakehouse and Delta tables there. Before we open Fabric, I would like to know that I spent a ton of my free time creating these videos for you, and that's why I would like to hit that like button and subscribe to the channel for more Fabric content. This doesn't cost you anything, and I would highly appreciate that. Also, you can join my YouTube channel as a member and get some exclusive perks, like early access to many of my videos, members-only videos, priority replying comments, and much more. And as a cherry on top, the theory slides in the video are available for channel members to download. And another way of showing support is to buy me a cup of coffee by clicking the Buy Me a Coffee link in the description. But now, let's go to Fabric. Now we are in Fabric and I have my DP600 tutorial workspace open. During the previous episode, we already created this Lakehouse to this workspace. Now let's open up that Lakehouse. As we can see, the Lakehouse has two sections. We have the tables and then we have the files section. To the file section, we can actually upload raw files. And I have created this subfolder here that can be very easily created from this UI by clicking this new subfolder button. To this subfolder, I have uploaded this one txt file that is now sitting there. So this is an example that we can add raw files to our Lakehouse that are any format. So the file format doesn't really matter when we store them to this file section. And also from this view, we can upload another file to this folder by uploading more files, and then we are going to upload this movies one CSV, and then we are going to click upload, and then it will upload it to this folder. And now we have two files there. Then we have the table section of our Lakehouse where our Delta tables live. And actually this is a schema-enabled Lakehouse. We have two types of Lakehouse. We have Lakehouse with schema and Lakehouse without schemas. And basically schemas are these just typical database schemas to which we can use then to group those tables. But yeah, we have the DBO schema that is there by the default, and then we have this DP600 episode 3 schema that I have created here before this demo. And there we have three tables. We have this sales no part, sales part 1, sales part 2. And basically here we have this sales data that is exactly the same, but now I have just partitioned that data differently to these Delta tables. We can check out how that looks. So let's open up this table here that doesn't have any partitions. And here we can see the sales table. Basically this table is very similar that we covered during the theory section when we talked about partitions. Then these other two tables, we have exactly the same data, but now it is partitioned under the hood a bit differently. And now, as you probably can tell, we are looking at the table representation of the Delta table. But actually from this drop-down, we can change to the file view and see the raw files here. Basically, here we can see that file structure that we have these Parquet files here, and then we have this Delta log that keeps track of those files. And we can quickly check out the code that have been used to create these three tables. So here I have this Spark SQL notebook that I have used to create the data, and then I have created the schema, and then I have created the first table without any partitions, and then I have created the second table with partitioned by category. And then I have created the last table, and then I have partitioned the data by category and region. So this allows us to create those partitioned Delta tables. Then also I have inserted the same data to those three tables. So that's why we can see the same data there, even though they are partitioned differently. But yeah, let's go back here and now let's check out the partition 1 table and let's change to the file view. Now we can see these partition folders here that are using that category column to partition the data. And underneath these, we should have Parquet files like we have here. So basically this is now partitioning the data based on the category column. And for example, in this category C folder, we have all the rows that have that category C there. For example, if we check out the table view, all the C columns, or basically these last 2 rows, would be in that specific Parquet file. And then we have this third table that have been partitioned by 2 columns. So first we have the category, and underneath that we have the region. So now the table will be divided / fragmented to even more Parquet files. And like covered in the theory section, this partitioning should be only used for very large tables. And the table that I'm using here is not really a good candidate for partitioning, but I'm using it just as an example so that you can understand the concept of partitioning. Then also during the theory section, we talked about the Delta table optimization and maintenance. And here, if we actually click these 3 dots, we have this maintenance tab here. And here we have those things that we talked about during the theory section. So we can run here that optimize command that will basically pack those small Parquet files into bigger ones. And then we're also able to apply that V order here. Then we also have the possibility to run the vacuum command here. That would basically remove those old files that are no longer referenced by the latest version of the Delta table. And of course, we can use the code to run these same commands as well. So for example, here I have some code that would run the optimize command and then run the vacuum command for one of those tables. So we don't only have to rely on the UI when doing these table optimizations and maintenance operations. And it would be quite a pain in a larger environment with thousands and thousands of Delta tables to click all of those through and optimize and vacuum them. So basically we could, for example, build some maintenance runs that would be scheduled, and they would run those commands to all the Delta tables that they can find in a Lakehouse. And before continuing with this video, I would like to remind you about the Certiace platform that can be found on certiace.com. I'm one of the co-founders of this platform, and this platform offers free custom-made practice questions to Microsoft certification exams. So after watching this video, go check out certiace.com. But now let's continue with the video. Next, let's create a new Lakehouse to this workspace. Let's find a Lakehouse from this list, and then we're going to name that, and we're going to have that Lakehouse as schema enabled. And let's create a Lakehouse. And to this Lakehouse, I want to define a shortcut from that previous Lakehouse. So we can go here and we can actually create a new schema shortcut to this Lakehouse. So let's click that, and then we are going to select one of the Microsoft OneLake sources. As you can see, we have some other sources for the shortcut as well, but now I'm going to create an internal shortcut here in Fabric. So let's select OneLake, and then we're going to select the Lakehouse that we used previously, and here we are going to select the schema that we had in that Lakehouse that we created via that notebook. So let's click next, and then we are going to create a shortcut to that schema. And now that has been created, and we can see that tiny shortcut icon there, that indicates that this schema is actually a shortcut. And under this, we should see those same tables that we had in that other Lakehouse. So basically, now we have created a shortcut to this schema, and that data is not physically copied. We are just referencing that same data, but now via this different Lakehouse here. Also, underneath the files, we can also create shortcuts, and we can also create shortcuts to other external places. But now let's create an internal shortcut to that same Lakehouse, and now let's select the file section, and I'm going to select the folder with those 2 files, and we're not going to do any transformations, so we're going to skip that, and we are going to click create, and this will then create this file shortcut here, and there we can see those 2 files. So now again, we are not physically moving the files, we are just referencing them via this Lakehouse. And this shortcut concept would work the same with those other sources that are external to Fabric. So we could, for example, create a shortcut to AWS S3 bucket, and then we would be able to see files sitting in that bucket via this Lakehouse, even though those files would be physically in that S3 bucket. Next, let's talk about these different interfaces that we can use to interact with Lakehouse data. Basically, now we are using this default interface that is basically the Spark interface that we can use to interact with Lakehouse tables and Lakehouse files. So we have this main interface that we can use to manipulate data, mainly with notebooks and other tools to, for example, write data to this Lakehouse, to Delta tables, and also to the file section. But then we have that other interface with Lakehouse that is the T-SQL interface. But that interface is read-only, so we cannot use that interface to manipulate data, but we can use that to read data in our Lakehouse table section. We can actually see that interface by going to this top corner, and here we can see that now we are using the Lakehouse interface. But then we have this SQL Analytics endpoint interface that we can use to query the data via using SQL, and more specifically T-SQL. I can click here and change to that T-SQL endpoint of the Lakehouse. Also, we would be able to open the same interface from the workspace, and here we can see that we have a Lakehouse and then we have the SQL Analytics endpoint, and from here we can get to the same place. But basically here we can see the Lakehouse now as this kind of a traditional database where we have these schemas and then we have tables underneath those schemas, and then we have also views. And by the way, to this SQL Analytics endpoint, we would be able to create views that could be used via this endpoint, but those views wouldn't be visible in that Lakehouse endpoint. And like said, we can query the data using T-SQL with this endpoint. For example, select top 100 rows from that sales no part table. And here we can see the data, and here's the T-SQL code for that. And when I say that we can use this T-SQL endpoint to query our Lakehouse like we could query like a traditional database, I really mean that. So that we can use tools like SQL Server Management Studio or SSMS to access that endpoint. And here we can see those two Lakehouses that we have here. So here we have the first Lakehouse and here we have the second Lakehouse. And actually here we can see those shortcutted tables as part of that second Lakehouse, and we would be able to query them as well. And now using this SSMS, we are able to query these tables, and this time let's query these shortcutted tables just to illustrate that that works as well. And now let's select top 1000 from that shortcutted sales part 1 table, and there we can see the data. But like said, this endpoint is read-only, and if we would try to run some commands that would actually update the data, for example with this update command here, we wouldn't be able to do that. And here we can say that it gives us this error message that this is not supported via this endpoint. But like I already mentioned, this endpoint supports creating views. So for example, let's create a view on top of that table, and now it has been executed. And now if we check views, we should have that view underneath there, and there we can see that view. But remember that this view is now created to this T-SQL endpoint, and it is not available via the Lakehouse endpoint. And if you're wondering how you can use tools like SSMS to connect to these Lakehouse T-SQL endpoints and also the warehouses in your workspace, you can go to the settings here, and here you can find the SQL endpoint, and here you can find the SQL connection string that you can use to connect to the workspace, and there you can find those SQL endpoints and warehouses that are available in the workspace. And that was all that I wanted to cover today. I hope you learned something new about Delta tables and a Lakehouse today. And if you like to continue your learning journey towards getting that DP600 badge, check out the next video in this series. But now I thank you for watching and see you in the next video.